Welcome to Chapter 5, Section 2, entitled Evaluate and Graph Polynomial Functions. As always, we'll do some vocabulary. And a polynomial is first up. It's a monomial, or the sum/difference of monomials. Now, basically what it means is it's multiple terms. So a polynomial will look like something that is x squared plus 3x plus 4. Right? Each of these is a monomial, and it's the sum of monomials. A polynomial function is a polynomial in function form. That means you're going to have f of x equals some polynomial expression. 2x cubed plus 4x squared minus 5. That's a polynomial. Synthetic substitution is a method that replaces the plug-in method. Now, really what we're doing with synthetic substitution is, well, you're going to use synthetic division to find some zeros. And it's going to be the same method, or the same process of synthetic substitution. All right, and behavior. There's real fancy ways of writing this. You can say x goes to positive infinity. That means it's going to the right. So if you have a graph, here's the origin, and the x-axis going to the right goes all the way to positive infinity. X going to the left is x going to negative infinity, which means left. So you can either use this terminology or just right and left, all right, to understand the process. As far as up is concerned, that's the other part of the graph. You could say, well, first of all, please remember, write this in your notes, that f of x and y are the same thing. They're equal. So that means x goes to infinity, y goes to infinity. That means up. So it should make sense that y goes towards negative infinity is down. That's how this is set up. So, identifying some pieces. I need to give you a little bit more information. The degree is equal to the highest exponent. The type is equal to the matching degree equation. So what that means is a constant has a degree of 0. Linear has a degree of 1. A quadratic has a degree of 2. A cubic has a degree of 3. And a quartic has a degree of 4. And that's where we're going to stop. So you should be able to look at any equation now and find the highest exponent to tell its degree. The type by matching the what type of degree it is, and also you should be able to determine the leading coefficient. The leading coefficient is the number or coefficient of the degree term. So, let's look at this. Decide whether the function is a polynomial function. If so, state whether, write it in standard form, and state its degree. Right, you also have to understand, let's go back to the definitions here. Polynomials, they have nice exponents slash variables. All right, that means that at no point will you have an x to the -2. That is not a nice exponent. That's also not a nice variable. So when looking at this first example, decide whether it is a function. Well, right here, the function is not a polynomial function because the term 4x to the 2.5 has an exponent that is not a whole number. It is not nice. If you take a look at B, the function is a polynomial function written as. Alright, so standard form, you put highest first. So you look at that and you should see that 9x to the 4th, the highest exponent, plus, and then a positive x squared, and then a positive 3.7x is in standard form. Looking back at the definitions, a degree is the highest exponent, so the degree is 4. And the leading coefficient, if you look at the definitions, is 9. Alright, so taking a look at this, we state the degree. Degree is the highest exponent, therefore it is 4. The type, a 4th degree means a quartic. And then the leading coefficient is the number in front of the degree term, -3. And all that information will be useful a little later. All right. So let's look at what synthetic substitution is. So the first thing you're going to do is write the coefficients of x in order of decreasing exponents. You're then going to write the value of x to the left, bring down the leading coefficient. So this is basically step 1, step 2, step 3, step 4. Multiply the leading coefficient by, we'll say 2, and write the product under the second coefficient. And then I'm going to write the word add. Multiply the previous sum by 2 and write the product under the second coefficient. Add and repeat for all remaining coefficients. So let's take a look at all of those steps. Step 1, write the coefficients. 2, 3, -6, 3. Please note this 0. You're missing an x term. So you have to show those zeros. Step 2, write the value of x to the left. Well, the value of x tells us that it's 2. Step 3, bring down the leading coefficient. That's a 2. Write the step 4, multiply the leading coefficient by 2 by the x value. 2 times 2 is 4, and we add. Multiply the previous, 14. 2 times 7 is 14, and we add. Multiply, add. Multiply, add. So f of 2 is 35. What this avoids for us is now we don't have to worry about 2 times 2 to the 4th plus 3 times 2 to the 3rd minus 6 times 2 squared plus 3. We don't have to do that. We just follow the synthetic substitution way, and it gives it to us right away. So let's take a look at number 1, guided practice number 1. It gives us a function. It is 13 minus 2x. We're asked to find out whether it is a function we now have to also find what the standard form is. Has the highest exponent first. We're supposed to find the degree, which is the highest exponent. We're supposed to find the type. So since the degree is 1, that means this is a linear function. And then we find the leading coefficient, which should be -2. So that's guided practice number 1. Guided practice number 2, we don't have to do number 2. We're just going to do number 4. Number 4. It says use direct substitution to evaluate for the given value. Direct substitution is plug in. Direct substitution, you plug in the value and you solve. So for number 4, we're given that f of -2 should equal -2 to the 4th. 2 times -2 cubed. 3 times -2 squared. Minus 7. So this basically 16 minus 16 plus 12 minus 7 becomes 5. Or we use synthetic substitution, which means we're checking -2. We're writing the coefficients. -2. Oh, I'm sorry. I'm looking at the wrong problem. This is number 4. So number 4 tells us 1, 2, 3, 0. 1, 2, 3, 0, minus 7. So the steps were drop down the leading coefficient and multiply. From there we add and we multiply. From there we add and we multiply. There we add and we multiply. So you can see both methods give us a solution of 5, and we should be happy with that. All right, end behavior. All right, now this is very, very complicated for something that shouldn't be. The terminology you're being asked to use is something you'll use in math analysis. I want you to understand the concept right now. The concept is that here's a graph. The last thing this graph does when it's going to the left is it's going up. When it's going to the right, it's going up. This graph here, when it's going to the left, it's going down. As it goes to the right, it's going up. All right, that's how these things are set up. Now the terminology is a little harder to understand. Left, of course, from the beginning, is x goes towards negative infinity. But if the leading coefficient is greater than 0 and n is odd, so this part right here, this part is important. If it's a positive leading coefficient with an odd exponent, then as f of x goes towards negative infinity, x goes towards negative infinity. And then the other one is true as well. As f of x goes towards positive infinity, it's also going towards positive. So the flip is true as well. If a is less than 0 and n is odd, now it reverses. If a is greater, if it's even, they always go in the same direction. So basically, you're looking at right here. This will help you to just kind of memorize it. If a is greater than 0, and it's an even degree, then they go in, they're always going up. If it's an even degree and a is negative, then it's going down. All right, so you're supposed to make a table for this and then graph it. So I'll work on the table. You pause the video, I'll pause the video, and we'll work on our own for a little bit. All right, so here are your points using this equation. So when I write here, well, -3 definitely is not going to work, but 0, -1, 1, 2, 2, 3, 3, -4, -1, 0, -2, way up there. Oh, I'm sorry. Kind of maybe mixed up some of these. So let me start over. -2, 11 is way up here. -1, 0. 0, -1. 1, 2, 2, 3, 3, -4. So your graph looks kind of weird. Something like that. So, with layman's term, I would say left up, right down, because that is what it's doing at the very end on this graph. The degree is odd, and the leading coefficient is negative. So if the leading coefficient, that means y value, goes up to the left, goes down. Like I said, using layman's term here, so you understand the process is fine. All right, guided practice number 6, use synthetic substitution to solve f of x equals 5x cubed 3x squared minus x plus 7. So, top 5, 3, negative 1, 7. You can do synthetic substitution using x equals 2. So drop down the leading coefficient and multiply. Multiply. So 57 is the right answer. That is using synthetic division. All right, we are almost done. So use synthetic division, coefficients across the top. Put this part right there, drop that. All right, negative 25 is your answer. All right, check and complete the following exercise. So we're graphing this. So you're going to want to make a table of values. So pause the video, make a table of values. All right, so you're going to pause the video, and you should have gotten a graph that kind of looks like this. All right, like this. And back down again. All right. So if we're dealing with end behavior for this, you're going to say the end behavior to the left is going down. The end behavior to the right is going down. That's how you can set this up. Okay, guided practice number 9. Graphing the polynomial. Well, you're pretty much going to make a sketch on your calculator and make a table of values and go from there. Alright, so that's it. Don't forget to do the rest of the guided practices. This part here will be done in class.